Hello friends, let us now learn some important points about the differences about the digital radiographic systems. In the digital radiographic systems, first we will learn about the computer radiography. In the next class we will learn about the digital radiography. So, digital radiographic systems are of two types. One, we have computer radiography. Second, we have direct radiography. Computer radiography and direct radiography. Computer radiography is an indirect conversion using storage phosphors, which we will deal in this class. In the next class, we will learn about the direct radiography, which includes indirect conversion and direct conversion. Indirect conversion using scintillators, that is thin film transistors or TFTs, or scintillators like charge coupled devices, or it can be direct conversion using photoconductor FPDs or selenium drum. So, computer radiography. So, if you see how a computer radiography works, so this is the patient. Okay, the patient is on the X-ray table. So, this is the X-ray tube. So, we put a cassette behind the patient, and when X-rays fall onto the patient, few of the X-rays are attenuated by the patient, and the remaining X-rays, which is similar to the latent image, those X-rays are focused onto the phosphor image plate. So this is image plate. So this image plate will contain a photostimulable phosphor. So this is the image plate, which is nothing but cassette in computer radiography. So now once the X-ray exposure is done, we will remove this cassette from this uh, machine, and we will introduce this cassette into this CR reader. So this is CR reader, which will read the information present in the cassette. So the cassette was made up of phosphostimulable phosphor image. So this phosphostimulable phosphor, most common phosphor material used in this image plate is europium activated barium fluorohalide. Europium activated barium fluorohalide is the most common phosphor used in photostimulable phosphor. So there is also a detective layer in this photostimulable phosphor, which contains the phosphor crystals. So it contains the phosphor crystals, and these phosphor crystals are actually embedded in a resin. Okay, phosphor crystals are embedded in resin. Next, if you see the X-ray exposure in the patient, the X-ray system, as we have already seen, this will release X-rays. These X-rays are, few of them are attenuated by the patient, and few of them reach the photostimulable phosphor detector, and from there they are read by an image reader. From there to the image scaler, then image is recorded, and finally we get the image from computer radiography. So let us see the actual process, what happens in the computer radiography. First, here there is patient, and this is the X-ray tube. So now the X-rays from the patient, are focused onto the X-ray tube. When the X-rays from the patient are focused onto the X-ray tube, few of the X-rays are attenuated by the patient, and the remaining X-rays reach the storage phosphor. Okay, once the X-rays reach the storage phosphor, these X-rays are focused onto the storage phosphor. Now these X-rays transfer their energy into the electron. So the electron in the lower energy states acquires the energy from the X-ray photon, and it gets excited. Once it gets excited, it goes to the higher energy state. Now the electron from the lower energy state has now gone to the higher energy state. So when the electron from lower energy state goes into the higher energy state, now here it stays in this stage. Okay, so the X-ray image is logged, or has a latent image. In this place, the X-ray image is logged, has a latent image in this stage. So this is photostimulable phosphor. Now this cassette here is now removed, and it is introduced into the CR reader. So what happens is, this is the CR reader, and the cassette is introduced into the CR reader. Now the When the cassette is introduced into the CR reader, now the laser beam is applied to the cassette line by line. So line by line, the laser beam reads the cassette. Okay. So when the laser beam is applied to the cassette, so the laser beam now hits the excited electron. So this excited electron, due to the laser beam, it will come back to its original position and it will release blue light. So this blue light is released from the phosphor. Now, once the blue light is released from the phosphor, there is something called as photomultiplier or AD converter. This will convert the blue light into electric charges, which is seen visually as an image. So this is how the computer radiography works. So let us see the same process one by one clearly. So this is the patient. This is the X-ray tube. Okay, the patient is on the X-ray machine, X-ray table. So on the X-ray table, here there is the cassette. Okay, now X-rays are exposed. The patient is exposed with X-rays. Few of the X-rays are attenuated by the patient and the rest reach the cassette. Here in the cassette there is an atom, atom which has electron and proton. So the X-rays now, so this is the, sorry, okay. So this is the electron. So the X-rays will now hit the electron. When the X-rays hit the electron, the energy from the X-rays is transferred to the electron and this electron now excites to the higher energy level. So now the electron is excited to the higher energy level. So when the electron is excited to the higher energy level, it becomes unstable. So this is an unstable state. Okay, so the energy of this X-ray is stored in the form of latent image. Now this is the state. Now here in the readout process, now the cassette is removed from the X-ray table. So in the X-ray table there is this cassette, right? Now this cassette is removed and it is placed into the CR reader. This is the CR reader. When you place the cassette inside the CR reader, now this CR reader will, when you place the cassette in the CR reader, now the CR reader will produce the laser light. Okay, it will focus laser light or it will uh, scan the image with the help of the laser light. So the exposed cassette is now read, or this CR reader or scanner, inside the CR reader or scanner there is a focused linear beam which scans this plate line by line. Okay, when it scans this plate line by line, already we have an atom, then electron, sorry, this is an atom with nucleus and the electron. Electron is now in higher energy state. Now this laser light will stimulate this trapped electrons and these electrons will come back to their original ground state. Now the electrons have returned back to their ground state. In the process of when the electrons from higher energy state return back to the lower energy state, they release energy in the form of blue light. So this blue light is called as photostimulable luminescence. The amount of blue light emitted is directly proportional to the amount of X-rays which are present here at this step. Okay, now this blue light is converted to the electrical signal or electrical signal by something called as analog to digital converter, by a machine called as analog to digital converter. Okay, so this electrical signals are converted to the are seen as an image on the computer. Okay, in the computer they are seen as an image on the computer. Next, so finally, if you see the trapped electrons, there are many trapped electrons. So most of the trapped electrons will return back to their original state, definitely. But there will be few electrons which are still trapped in the higher energy states only. Okay, so here this electron is still trapped in the higher energy state. So there might be few electrons which are still trapped in the higher energy state. When the electrons are still trapped in the higher energy state, and if you try to re-expose this film to for another patient, So these all will result in fog of the X-ray film. So as a result, to remove this this cassette is exposed to a white light. So this white light, which is of high intensity, so this is exposed to a high intensity white light. So when this is exposed to a high intensity white light, so this will flushes all the trapped electrons. So all the trapped electrons will come back to their original state, and thus this will erase the information present in the cassette, and thus it can be reused again for the next fill. So these are the important points of how CR is done. So this is the CR image. So this is the computer, and this is the CR reader, and this is how the image is displayed. So the main important strengths of CR system is greater exposure latitude. So there is wider dynamic range is present in uh, computer radiography compared to film screen systems, and there is better visualization across densities is seen compared to film screen system. There is fewer repeats because of the wider latitude. There are fewer repeats. We can reuse the phosphor plate again and again. So reusable phosphor plates are present, and it is cost effective compared to DR because DR is more expensive. So it is cost effective compared to DR, and it has a good response curve, and thus linear response curve will result in better contrast resolution and post processing. So these are the important points about computed radiography. In the next class we will learn about digital radiography. Thank you.